or Collins reagent. So there are different oxidizing agents. So we will see one by one what are the different oxidizing agents and their works. Okay, how they work or how they oxidize. First of all, we will see acidified potassium dichromate. Okay, this is a very strong oxidizing agent. That means firstly it oxidizes alcohol to aldehyde and then it further oxidizes aldehyde to carboxylic acid. So it is a very strong oxidization. It does not stop upon reducing to aldehyde. Further it reduces aldehyde to carboxylic acid. Okay, here we will see the mechanism of oxidation of alcohols using acidified potassium dichromate. So first of all, this potassium dichromate will dissociate into two K plus ions or two potassium ions and chromate ion. This chromate ion is Cr2O7 minus. The structure of this chromate ion is 2 chromium bonded through one oxygen atom. This much. When 2H plus is added from 2H plus from this H plus is from H2SO4. Now when 2H plus is added, this forms chromic acid. We can say H2 Cr2, then 2 to 4 5 6 7 H2 Cr2O7. This is chromic acid. This forms chromic acid. Now this chromic acid, upon treating with water, this sorry. So this is the chromic acid. After treating with water, it forms H2 Cr O4. This is chromic acid, and now this chromic acid reacts with alcohol to form aldehyde. So in the first step, this chromic acid protonates. As there is presence of an acid H2SO4. This H plus is from H2SO4. So first of all, it protonates and it forms OH plus, and then there is attack of the alcohol. Alcohol attacks to chromium center and there is breakage of this chromium oxygen double bond. And there is formation of CrOH, OH and double bond O. Now this is OH plus, so this gives electron to the O plus and removes H minus. This H minus is further consumed by this OH and it becomes OH2. Now this OH2, this is a good leaving group as water. So this water is removed and there is formation of aldehyde. Now this aldehyde, this will go on further oxidation and this will form carboxylic acid. This forms carboxylic acid in case of primary alcohols only, because in a primary alcohol it forms aldehyde and then aldehyde it undergoes further oxidation to carboxylic acid. Okay. Then we will see, as we have discussed, this is secondary alcohol. So this secondary alcohol produces ketone, and this ketone is not further oxidized to carboxylic acid, but in case of primary alcohols it reduced to aldehyde, and this aldehyde then further oxidized to carboxylic acids. Okay. And if we continue vigorous oxidation in case of this ketone, if we consider one example like this is isopropyl alcohol. The isopropyl alcohol undergoes oxidation with acidified potassium dichromate. This produces acetone. And if we maintain the vigorous reaction conditions and this further undergoes vigorous oxidation, this may break here and there is formation of acetic acid and formic acid. Then we will see another oxidizing agent, that is PCC, which is known as pyridinium chlorochromate. Its main constituents are this PCC consists of generally pyridine plus CrO3 chromium trioxide, then I have another HCl. This is pyridinium chlorochromate, okay. PCC, or it is known as Collins reagent. The benefit of this Collins reagent, rather than using acidified potassium dichromate, is this Collins reagent or PCC oxidizes primary alcohol to aldehyde only. It does not have excess oxidation or further oxidation of aldehyde to acid. This is the benefit of using Collins reagent or PCC over acidified potassium dichromate. So if you treat this primary alcohol with PCC, CrO3, this produces aldehyde. Certainly it does not form carboxylic acid. So the mechanism of this reaction is, when the alcohol is treated with CrO3, the lone pair of oxygen attacks to chromium and there is formation of OH plus. Now this OH plus forms C single bond O single bond Cr. Now this break down to form aldehyde. Okay. For this oxidation, here we are removing one H from the alcohol and another H from the carbon atom, or we can say this is alpha carbon. This is alpha carbon. Alpha carbon means the carbon to which the OH group is directly attached. So to this alpha carbon there should be at least one alpha hydrogen, so that the alpha hydrogen should be removed along with that hydrogen of alcohol. So if any alcohol, or you can say the tertiary alcohol, that doesn't have alpha hydrogen, okay, if this doesn't have any alpha hydrogen, so this will not undergo oxidation. The tertiary alcohol will not undergo oxidation in presence of PCC or Collins reagent to undergo oxidation from alcohol to any carbonyl compounds. Okay. Okay. I hope I skipped one of the reagent oxidizing agents, and that is a heated copper. Okay, let us see. Now the oxidizing agent is heated copper. Repented copper heat. It is around like 473 Kelvin at 200 degrees Celsius. This is also one type of oxidizing agent. So if you will see, let us consider one alcohol like CH3, CH2 or ethanol. If we treat with copper 573 degree Kelvin, or you can say heated copper, this will produce CH3, CHO or acetaldehyde. This is primary alcohol. So when primary alcohol treated, it forms aldehyde. So there is another question I have just given to the students. What happens when isopropyl alcohol is passed over heated copper? If we consider isopropyl alcohol, CH3 CHOH, then CH3. This is one of the secondary alcohol. When this secondary alcohol is heated upon heated copper, this removes hydrogen from one hydrogen from here, one hydrogen from here, and this forms acetone. Okay. This heated copper is one of another one type of oxidizing agent. Then we will see in among the reactions. Then we will see the iodoform reaction. Generally, this iodoform reaction is used for the testing of primary alcohols. Like if you consider one primary alcohol along with one tertiary alcohol or something, we can distinguish the primary alcohol from other by using iodoform reaction. In iodoform reaction, as mentioned in the product, this forms iodoform. Iodoform, that means CHI3. As chloroform, that is CHCl3. Bromoform will be CHBr3. Hence iodoform will be CHI3. This is a yellow precipitate. Okay, this reaction takes place in presence of NaOH plus I2. This NaOH and I2 reacts to form NaOI plus HI. Then this NaOI reacts with primary alcohol to form aldehyde. Simply this acts as an oxidizing agent to form aldehyde, and that aldehyde further reacts with NaOI to form CI3CHO, and this CI3CHO reacts with NaOH to form iodoform. This iodoform is a yellow precipitate that can be used for the distinguish of primary alcohol. Like if there is one question, how to distinguish between like if there is one question, distinguish between ethanol and phenol. How will you distinguish? This ethanol will give iodoform reaction. Like if we treat with NaOH plus iodine, this will form NaOI, and this NaOI further treatment with ethanol, this will form CHI3, that is iodoform, yellow precipitate. But phenol, this will not react, or this will not form any yellow precipitate. Okay. Next we will see diols. Now we are seeing monohydric alcohols. Okay. Next we will see diols. What are diols? Diols are the chemical compound which contain two OH groups. In alcohols, simple primary or monohydric alcohols, we are seeing like methanol, CH3OH, or ethanol, C2H5OH, that contains a single hydroxy group, single OH group. The diols, those contain two OH groups. Alkyl halides like vicinal dihalides, alkyl halides like dial dihalides. There are two types of dihalides. One is vicinal, one is geminal. Vicinal means, if you consider a vicinal dihalide, that means the two halogen atoms that are connected to two different carbons. Like if you see dibromoethane, CH2Br, CH2Br, this is vicinal dihalide. If you consider geminal dihalide, that means two halogen groups are connected to a single carbon atom. That is called geminal dihalide. Okay. Similar to that of the dihalides, in these diols also there are vicinal diols and there is geminal diol. If we consider vicinal diol, that is This is known as ethylene glycol, or simply we can say glycol. This is one type of vicinal diol. In this vicinal diol, two OH groups that are connected to two different carbon atoms. But if we consider geminal diols, these two OH groups are connected to single carbon atom. But this geminal diol is unstable. This loses water to form aldehyde. Okay. In case this is connected with one H group, if there is like CH3, COH, OH, CH3. Now this will lose water to produce acetone. So geminal dihalides, geminal diols are comparatively unstable because there is two OH group on one single carbon atom, that is unstable. So it loses water to form carbonyl compound. Okay. Next we will see the methods of preparation of diols. Okay. Diols can be prepared from alkenes. Okay. If there is addition of one OH group, that is known as hydroxylation. Okay. If there is addition of two OH group, that is known as dihydroxylation. Okay. If we are adding in a reaction, if we are adding two OH groups, that is known as dihydroxylation, and these reagents which are used for dihydroxylation, these are known as dihydroxylating agents. So here we will study two dihydroxylating agents. First one is alkaline KMnO4, or we can simply write KMnO4 white minus. This is one of the dihydroxylating agent, and another one is osmium tetroxide OSO4. That is also one type of dihydroxylating agent. So if you see mechanism, this KMnO4 will break down to K plus plus MnO4 minus. This MnO4 minus, it is manganate ion, permanganate ion. So first of all, this double bond will attack to the oxygen atom. This oxygen will transfer electron to manganese, and this double bond will break and attack to the double bond. There is formation of this type of intermediate. Okay. Now on basic hydrolysis of this intermediate, there will be bond cleavage from here and here, and there will be formation of diol, that is syn diol. Syn diol means these two OH groups will have same stereochemistry. Okay, if we consider the stereochemistry, these two OH groups will have same stereochemistry. If one is waste, another will be also waste. If one is in dash position, another one will be also in dash position. Okay. So this is one type of dihydroxylation. This is known as also syn dihydroxylation. And another hydroxylating agent that is used is osmium tetroxide, OSO4. Okay. This is also similar to that of the basic or alkaline potassium permanganate. In this also, double bond from carbon attacks to oxygen, oxygen transfer electron to osmium, and then another osmium and oxygen double bond breaks down and attack to the second carbon atom. There is formation of this type of intermediate, and this type of intermediate on top of the hydrolysis, there will be breakage of bond from here, and there will be production of diol. Okay. This is also syn dihydroxylation. This is one type of syn dihydroxylation. And next method we will see the production of diols by hydrolysis of epoxides. As I have told in the first class or first video, epoxides are cyclic ethers. The oxygen is bonded to two carbon atoms in a cyclic manner. Okay. When we hydrolyze this epoxide, the lone pair from oxygen attacks to one of the carbon atom, and there is breaking of carbon oxygen bond. The formation of OH2 plus, and this negative charge will conjugate one of the H plus, and this will denote electron to O, and there will be formation of diol, and this is not syn dihydroxylation. This is NT. That means the produced alcohol have opposite stereochemistry. Okay, this is epoxide. Next we will see the preparation of epoxide. Epoxide can be prepared by two methods, by reacting with silicon and by reaction with pore acids. What is pore acid? A pore acid in which there is one of the peroxy linkage. Peroxy linkage, that means oxygen-oxygen single bond linkage. This peroxy bond that is formed, this is very weak. So this breaks down very easily and this oxygen atom, this is electrophilic oxygen atom. That means it is electron seeking. Okay. Now this there are two pore acids like benzoic acid. Generally we use first one is benzoic acid and second one is meta-CpBA. That means metachloro benzoic acid. Like if you ever see one alkene is reacting with MCpBA, any of the reaction it is given alkene reacts with MCpBA, that means this will form epoxide. Okay. So we can see this also in preparation of epoxides. Okay. In this pore acid, this oxygen is electrophilic oxygen. So this double bond attacks to this oxygen and the lone pair oxygen attacks to the carbon atom. There will be formation of epoxide. And then water attacks to the one of the carbon atom. Now, with hydrolysis, this forms trans diols. Okay. And another method for the preparation of epoxide is reacting oxygen in presence of silver with heat. This produces also epoxide. Okay. Next preparation we can see from alkyl dihalides like dibromo ethane. This dibromoethane react with potassium acetate, potassium acetate, or we can consider also sodium acetate to form this ester, and this ester undergoes hydrolysis in presence of base to produce diol and 2 sodium acetate. If we are using sodium hydroxide, if we are using potassium hydroxide, this will form potassium acetate like CH3 CO. Okay. This is a preparation of diol from alkyl halides. Okay. Next we will see. So now the preparation part is finished, I hope. Next we will see the reaction of dihalides. The reaction of diols with different compounds. If we see the reactions are similar to that of the alcohols. Like if we react this methanol CH3OH with sodium, this will produce sodium methoxide CH3OH plus half H2, similar to that of the diol. Like if we use glycol CH2OH single bond CH2OH. We consider one sodium, so this one sodium will first substitute one of the OH group, and this will further react with sodium to produce CH2ONA single bond CH2. Okay. So this is reaction with sodium. If we consider reaction with HCl, so if we consider like ethanol, like C2H5OH, if this reacts with HCl, so there will be protonation from H plus, this will be removed and there will be formation of C2H5Cl. Chloroethane, similar to that if we react with ethylene glycol CH2OH single bond CH2OH react with HCl, like 2 moles of HCl, this will form CH2Cl single bond CH2Cl. The reactions are similar to that of the Diols reactions are similar to that of the alcohols. Like if we consider another one, if we consider CH2OH single bond, CH2OH reaction with PCl5. This like 2 times reacting with PCl5, these two OH groups will be substituted with Cl, CH2Cl, single bond CH2Cl. The reactions are very similar to that of the alcohol, but in some cases the reaction is different. Okay, like if we see the reaction with thionyl chloride or reaction with SOCl2. If we consider one alcohol like CH3OH, monohydric alcohol reaction with SOCl2, this will certainly produce CH3Cl plus SO2 gas plus HCl gas. But in case of diol, this does not take place. So we consider CH2OH, single bond CH2OH, react with it SOCl2. The structure of SOCl2 like this: S double bond O, Cl and Cl. So this H and Cl they will combine. There will be removal of minus 2 HCl, and there will be formation of CH2 single bond O, then sulfur double bond O. The formation of this 1, 2, 3, 4, 5. 5-membered ring. If you see in any reaction, there is formation of 5 or 6-membered ring. These 5 or 6-membered rings are comparatively more stable. If you consider there is formation of 3-membered ring, that is comparatively unstable. So there is not formation of 3 or 4-membered ring. But instead, if there is formation of 5 or 6-membered ring, that is comparatively stable and this forms. Okay. Then we will go the dehydration of diols. Like as we have seen, by hydrolysis of epoxides, there is formation of diols. So if we dehydrate like CH2OH, if there is dehydration of minus H2, there will be formation of epoxide. Okay. The reagent which is used for dehydration of epoxide, there is no such reagent that is used, but in presence of heat, okay, this loses water and there is formation of epoxide. Okay. On heating like 773 Kelvin, which is around 500 degree Celsius. In heating, this loses water or there is dehydration. Sorry, please correct this. There is dehydration and there is formation of ethylene oxide or epoxide. Okay. Next we will see what if these diols are reacted with aldehydes or ketones. Okay. So in short we can say reaction with carbonyl compounds. Reaction of these diols with carbonyl compound. Let us consider if we take ethylene glycol with acetaldehyde. So there will be dehydration. Should consume one oxygen from here, one hydrogen from here. Then there will be minus of water and there will be formation of one cyclic compound CH2O, single bond CH2O, carbon and then H and then CH3, and there is formation of 5-membered ring. This 5-membered ring is comparatively stable, and this forms the product. If we consider this one also, methylene glycol with cyclohexanone, there will be minus of H2O, and there will be formation of this 5-membered ring. Okay. Okay, there is one important name reaction, that is pinacolone rearrangement. Okay, first we will see pinacol, then we will see pinacolone rearrangement. Okay, after this pinacolone rearrangement, we will move to the phenol part. Okay. First of all, let us see what is pinacol. It is diol if it is tetra substituted. This is known as pinacol, and there is rearrangement to pinacolone, which is one tertiary group, single bond to carbonyl. This is known as pinacolone. For this rearrangement, we treat this with acid, or we can say like sulfuric acid, H2SO4, and there is rearrangement. Okay, so now we will see the mechanism of this reaction. Okay, in the first step, if there is one OH group and there is an acid, so blindly or simply we can say there in the first step there will be protonation. If we consider these four are 4 methyl groups. Okay, let me write. These are 4 methyl groups. This is H plus. Okay. In the first step, this will protonate, and there will be formation of OH2 plus, 4 methyl groups attached. Now this is a good living group, and there will be removal of water and formation of carbocation. Okay. Now what happens? This is tertiary alcohol. In the next step, there will be migration, or we can say there will be shifting 1,2 methyl shift. This methyl from second carbon will shift to the first carbon, and there will be formation of tertiary group. This is OH, this is CH3, this is plus. Okay. Now the question arises. This is tertiary carbocation, okay, which is comparatively stable. So where there will be migration or when there will be 1 to methyl shift if already tertiary carbocation is present. Okay. So for that there is explanation is there. Okay. Please consider this tertiary carbocation. Okay. This is stabilized by 3 plus I or 3 electron donating groups. Okay. But here if we consider this is moved to, let us ignore all these groups and let us consider about this OH. Okay. This OH has 2 lone pairs which can donate its electron, and now this can be resonance stabilized as double bond OH plus. So this is what? This is resonance effect or mesomeric effect. This is plus M effect. So if we compare between, when there is comparison between inductive effect and mesomeric effect, the more priority will be given to mesomeric effect. So plus M effect will be higher priority over plus I effect. So this rearranged product, this is more stable due to plus M effect, which is resonance stabilized. Okay, if you see the resonance stabilized structure, okay, if you see the resonance stabilized structure of this one, this lone pair will move here. There will be formation of C double bond OH plus single bond CH. Okay, this is resonance stabilized. Now this ion or from this or from this, if you see 3 methyl group attached, single bond carbon, single bond OH, cross carbocation, single bond CH3. Now this will donate electron to form double bond. This will lose H plus. The H plus is starting in the starting. The H plus is consumed as a catalyst. So catalyst will be removed, and there will be formation of ketone, which is known as pinacolone, and this is known as pinacolone rearrangement. Okay. So in the next class we'll study about the phenols, the naming, the methods of preparation, the reactions. Okay. So that's it, all about the alcohols, monohydric alcohols and dihydric alcohols or diols. If you have any doubt regarding this, you let me know in the comment section. That's it. Thank you all.